Hello everyone, thank you for coming. Let's continue. Today it will be multi-component dark matter. First of all, I would like to stress that Hypersphere World as a model of a finite universe was proposed by Riemann in 1854. World-Universe Model follows this idea, albeit proposing that the world is stretching and filled with the medium consisting of stable elementary particles. Let me remind you the main result of the first presentation, medium of the world. Microwave background radiation, intergalactic plasma, far infrared background radiation speak in favor of existence of medium, which is an absolute frame of reference. Time, space, gravitation are closely connected with impedance, gravito-magnetic parameter, and energy density of the medium. There is no medium, there is nothing. Critical energy density of the world can be found by the Hubble's law. There is no need in general relativity. Medium consists of stable elementary particles, protons, electrons, photons, neutrinos, and dark matter particles. The relative energy density of dark matter particles is about 92.8%, and ordinary particles about 4.8% in the medium and 2.4% in macro objects. Maximum value of the velocity of electromagnetic waves equals to the value of the electrodynamic constant C. The most important gravitational and Hubble's parameters depend on the energy density of the medium, which is a homogeneous and isotropic. Thanks to revealed by Wurm interconnectivity of cosmological parameters, we show that the gravitational parameter that can be measured directly makes measurable all cosmological parameters which cannot be measured directly. Summary of the calculated by Wurm in 2013 cosmological parameters and experimentally measured parameters are presented in the following table. We emphasize that Wurm allows for precise calculation of values that were only measured experimentally earlier, like ambient temperature, far infrared background temperature P, and makes verifiable predictions with the other cosmological parameters like gravitational, Hubble's, ionized baryons, medium photons energy. You can compare these two columns, calculated and measured values, and guess when it happened. Dark stars. The basic feeling of many physicists is that dark matter does not exist because they believe that the dark matter constant was erroneously created due to a false analysis of the expected rotational velocity of stars in the outer range of spiral galaxy, and also presumably due to a lack of knowledge about other evidence for dark matter. In the following presentation, I will concentrate on a dismissal of this belief. I will provide a short review of the dark matter history for 240 years, in which great scientists were involved. John Michell was an English natural philosopher and clergyman who provided pioneering insights into a wide range of scientific fields, including astronomy, geology, optics, and gravitation. Considered one of the greatest unsung scientists of all time, he is the first person known to have proposed the existence of dark stars, and the first to have suggested that earthquakes travel in seismic waves. The American Physical Society described Mitchell as being so far ahead of his scientific contemporaries that his ideas languished in obscurity until they were reinvented more than a century later. The Society stated that while he was one of the most brilliant and original scientists of his time, Mitchell remains virtually unknown today, in part because he did little to develop and promote his own path-breaking ideas. In the paper for the Philosophy of Transactions of the Royal Society of London, read on 27th November 1783, Mitchell was the first to propose the existence of dark stars. Mitchell suggested that there might be many dark stars in the universe and proposed that astronomers could detect dark stars by looking for star systems which behaved gravitationally like two stars, but where only one star could be seen. Mitchell argued that this would show the presence of a dark star. It was an extraordinarily accurate prediction of binary systems, in which a dark star and a normal star orbit around the center of mass. In the Milky Way galaxy, there are a dozen such binary systems emitting X-rays. Please pay tribute to this genius physicist. The first known binary system was Cygnus X1, identified independently by several researchers in 1971, 188 years later. Can you believe it? It remains among the most studied astronomical objects in its class. The compact object is now estimated to have a mass of 21.2 mass of the Sun. Cygnus X1 is about 5 million years old. Though highly and erratically variable, Cygnus X1 is typically the brightest persistent source of hard X-rays with energy up to 60 kiloelectron-volts. Bessel, Lord Kelvin, Poincaré, Zwicky, and many other great scientists discussed various aspects of dark matter. The hypothesis of dark stars was developed by well-known scientists Ripamonti and Abel, Spoler, Fries and Gondola, Fries, Reitler, Dirac, and Spoler and Valur. In 2020, Genzel and Getz were awarded the Nobel Prize in Physics for discovery of a supermassive compact object at the center of our galaxy. This discovery confirmed one of the most important predictions of Wurm in 2013. Macro objects of the world have cores made up of the discussed dark matter particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cores. The first phase of stellar evolution in the history of the world may be dark stars powered by dark matter heating rather than fusion. Ely, Pauling, and Fries, in the article Supermassive Dark Star Candidates seen by GWST, wrote, the first generation of stars in the universe is yet to be observed. There are two leading theories for those objects that mark the beginning of the cosmic dawn: hydrogen burning population 3 stars, and dark stars made of hydrogen and helium but powered by dark matter heat. We showed that each of these following 3 objects, JADIS GS Z13, Z12, and Z11, are consistent with a supermassive dark star interpretation, thus identifying for the first time dark star candidates. Dark galaxies. A truly dark galaxy is an isolated cloud consisting only of dark matter. In some scenarios, it is possible that some optically dark objects may contain enough atomic hydrogen, HI, that a blind HI survey would detect them. A good example of dark object is the southwestern component of the binary system known as HI 1225 plus 01, discovered by Giovanelli and Haynes in 1989. While the northeastern HI component hosts a small star-forming dwarf, the southwestern component has no detectable stellar counterpart. It is not an isolated object, being part of an apparent binary system. Initially discovered in 2000, Virgo HI-21 was announced in 2005 as a good candidate to be a true dark galaxy. Mentioned et al. In the article 21 centimeter synthesis observations of Virgo HI 21, a possible dark galaxy in the Virgo cluster, say many observations indicate that dark matter dominates the extragalactic universe. Yet no dark structure of galactic proportions has ever been convincingly identified. Previously, we have suggested that Virgo HI 21, a 21 centimeter source we found in the Virgo cluster, was a possible dark galaxy because of its broad line width, about 200 kilometers per second, unaccompanied by any visible gravitational source to account for it. We have now imaged Virgo H121 in the neutral hydrogen line and find what could be a dark edge-on spinning disk with the mass and diameter of a typical spiral galaxy. Moreover, Virgo H121 has unquestionably been involved in interaction with NGC 4254, a luminous spiral with an odd one-armed morphology. We have also used the Hubble Space Telescope to search for stars associated with H1 and find none. The best telescope, none. The cloud is at the Virgo cluster's distance of 52 million light years. It is roughly 50 kilolight years across, about half the diameter of Milky Way starry disk. The strength of 21 centimeter emission indicates that the cloud harbors 2 multiplied 10 to the power 7 mass of the suns of atomic hydrogen, about 1/10 Milky Way supply. But the cloud's total mass is much greater, implying that, like most galaxies, including our own, it consists primarily of dark matter. Astronomers estimated the cloud's mass at least 9 multiplied 10 to the power 10 mass of the sun. Xu et al. Obtained HI mass 8.3 multiplied 10 to the power 7 mass of the sun of this galaxy. Their findings provide observational evidence that this galaxy is an isolated dark dwarf galaxy. This is the first time that an isolated dark galaxy has been detected in the nearby universe. A galaxy G0613 plus 52 has about the same characteristics of mass and gas content as a normal spiral galaxy. There are no galaxies within 112 megaparsec, making it a pretty isolated target. O'Neill et al. Found that it is an incredibly gas-rich galaxy. It is not demonstrating star formation like we expect, probably because its gas is too diffuse. At the same time, it's too far from other galaxies for them to help trigger star formation through any encounters. It appears to be both undisturbed and undeveloped. This could be our first discovery of a nearby galaxy made up of primordial gas. This is an artist's depiction of hydrogen gas observed in galaxy G0613 plus 52. The colors indicate the likely rotation of the gas relative to the observer: red away, blue toward. The question is, where did this hydrogen gas get an angular momentum? In the case of this galaxy 8.8 billion light years away, a radio signal 21 centimeter line was magnified by another galaxy acting as a lensing body. Roy said that This effectively results in the magnification of the signal by a factor of 30, allowing the telescope to pick it up. At the conclusion, binary galaxy systems, including dark galaxies, were discovered. HI 1225-01 by Giovanelli and Hamish in 1989. Virgo H121 with NGS 4255-54 by Minchin et al. In 2000. Prediction of John Mitchell of the existence of dark stars is valid for dark galaxies also. 21 centimeter emission. The 21 centimeter line refers to a forbidden transition in a neutral hydrogen atoms. It is produced by a spin flip transition, which means the direction of electron spin is reversed relative to the spin of the proton. The electromagnetic radiation produced in this line has a frequency of 1420 MHz that is equivalent to a wavelength of 21.11 centimeters and a transition energy 5.874 microelectron volts. This line has a very low transition probability, so it requires large amounts of hydrogen gas for it to be seen. According to Padovani et al., small amounts of atomic hydrogen detected as absorption dips in the 21 centimeter line spectrum are a well-known characteristic of dark clouds. The abundance of hydrogen atoms measured in the densest regions of molecular clouds can only be explained by the dissociation of hydrogen molecules by cosmic rays. Then two questions arise: where cosmic rays came from, and how to explain broad line width about 200 kilometers per second of 21 centimeter stars. Mondal and Barkana in article Prospects for Precision Cosmology with the 21 centimeter signal from the Dark Ages say, while exotic physics could be discovered, here we quantify the expected benefits within the standard cosmology. A measurement of the global sky average 21 centimeter signal to the precision of thermal noise from 1000-hour integration would yield a measurement within 10% of a combination of cosmological parameters. Precision cosmology with 21 centimeter fluctuations requires a collecting area of 10 square kilometers, corresponding to 400,000 stations. Is it reasonable or not? It seems to me unreasonable. Galactic rotation curve. In 2021, Ludwig, in his paper, Galactic Rotation Curve and Dark Matter According to Gravitomagnetism, wrote, most theories used to explain the rotation curve have been restricted to the Newtonian potential framework, disregarding the general relativistic corrections associated with mass currents. In this paper, it is shown that the gravitomagnetic field produced by the currents modified the galactic rotation curve, notably at large distances. The effects attributed to dark matter can be simply explained by the gravitomagnetic field produced by the mass current. I would like to stress this conclusion. A developed womb is based on gravitomagnetism. The explanation of the galactic rotation curve made by Ludwig is in a good agreement with the approach of womb. We emphasize that gravitomagnetism considers not only interactions between masses, but also between mass currents, producing gravitomagnetic field. Equations for gravitomagnetism were first published in 1893, before general relativity, by Oliver Heaviside as a separate theory expanding Newton's law. We don't know history of physics at all. Sorry. Superclasses. Galaxy clusters are particularly important for dark matter study. Mass-to-light ratio of the weirdest superclusters is about 300 times larger than that of solar ratios. Similar ratios are obtained for other superclusters. These ratios are main arguments in favor of presence of significant amount of dark matter in the world. Masses of superclusters can be estimated in two independent ways: from the scatter in radial velocities of the galaxies within clusters. Gravitational lenses can measure cluster masses without relying on observations of dynamics. It is experimental result. It was imaginations. That's why it is experiments. Sorry. Multi-component dark matter. Basic ideas. It is the main goal of ROOM to develop a model based on two-dimensionless parameters only: the dimensionless Rydberg constant alpha and the time-varying parameter Q, which is the measure of the size and age of the world. We often use well-known physical parameters, keeping in mind that all of them can be expressed through the basic units. Taking the relative values of physical parameters in terms of the basic units, we can express all dimensionless parameters of the world through the parameters alpha and q in various rational exponents, as well as small integer numbers and pi. In our view, there is no way to prevent an occurrence of the initial singularity in Big Bang model. A finite world must have gotten started in a principally different way: a fluctuation in the eternal universe with an extrapolated finite size that equals to the basic size unit of A. The size of this fluctuation can increase with a finite c gravitodynamic constant. Then there is no need to introduce cosmological inflation. However, a question about the mechanism of continuous creation of matter in the world arises, according to whom the eternal universe is the creator of the world's dark matter particles, which must have constant raised energies. In 1952, Nobel laureate in physics Nambu proposed an empirical mass spectrum of elementary particles with a mass unit close to 1/4 of the mass of a pion. He noticed that meson masses are even multiplies of a mass unit m0/2, baryon and also unstable lepton masses. The odd multiplies and mass difference among similar particles are quantized by 70 megaelectron-volts, in whom we introduce a basic energy unit E0 that equals to 70 megaelectron-volts, where H is the Planck constant. It is worth noting that the rest energy of electron equals to alpha E0, and the Rydberg unit of energy equals to half alpha cube E0. R is the Rydberg constant. Considering the main goal of room, two-dimensionless parameters only, the rest energies of dark matter particles should be proportional to constant alpha only. Indirect effects in cosmic rays and gamma ray background from the annihilation of cold dark matter in the form of highly stable neutral leptons in galaxies were considered in pioneer article by Nobel laureates in physics Lee and Weinberg in 1977, whom followed this idea. According to whom the world consists of dark matter, about 92.8% of the total matter, and ordinary matter, about 7.2%. It means that dark matter should play the main role in any cosmological model. It is the case in whom an ordinary matter is a byproduct of dark matter particles' self-annihilation. In our opinion, it is high time to make a paradigm shift for dark matter cosmology and classical physics. Dark matter particles. Following the mechanism discussed by Boyan et al., we proposed multi-component dark matter system consisting of two couples of co-annihilating dark matter particles, a heavy dark matter fermion, DMF1, 1.3 tera-electron volt, and a light spin zero boson Dirac, 70 mega-electron volts. That is a dipole of Dirac's monopoles with charge mu equals E over 2 alpha. E is the elementary charge. A heavy fermion DMF2, 9.6 giga-electron volt, and a light spin zero boson along 340 kilo-electron volt. That is a dipole of preons with electrical charge E over 3. DMF3, 3.7 kilo-electron volts, DMF4, 0.2 electron volts, and boson xenon, 5.3 microelectron volts. In frames of whom dark matter particles DMF1, DMF2, and DMF3 have rest energies which corresponds to rest energies of neutralinos, wings, and sterile neutrinos discussed in literature. DMM4 constitute the biggest shell of dark matter cores of superclusters. Dirac, which is the magnetic dipole of Dirac's monopoles, is introduced to explain the Dirac quantization condition. The quantum theory of magnetic charge started with a paper by Paul Dirac in 1931. In this paper, he showed that if any magnetic monopoles exist in the universe, then all electric charge in the universe must be quantized. The electric charge is in fact quantized, which is consistent with, but does not prove the existence of monopoles. Since Dirac's paper, several systematic monopole searches have been performed, but it remains an open question whether monopoles exist. In our opinion, all electric charges are quantized due to the existence of Dirac's, dipoles of Dirac's monopoles, which are the smallest building blocks of the structure of constituent quarks and hadrons, mesons, and baryons. A lobe, which is an electric dipole of preons with the rest energy 1/3 of electron energy, is introduced to explain all subatomic particles with electrical charge proportional to E over 3. Preons are the smallest building blocks of the structure of quarks and leptons. According to D'Souza and Kalman, in particle physics, preons are postulated point-like particles conceived to be subcomponents of quarks and leptons. We didn't consider binding energies of Diracs and LOs, and thus the values of their rest energies are approximate. They have negligible electrostatic and electromagnetic charges because the separation between charges is very small. They do, however, possess electrostatic and electromagnetic dipole momentum. Xenon is an analog of axion discussed in literature. It has the value of the rest energy 5.3 microelectron volt. Axion is a hypothetical elementary particle postulated in the Pecky-Quinn theory to resolve the strong CP problem in quantum chromodynamics. With a rest energy about 5 microelectron volts, axions could account for dark matter and thus be both dark matter candidate and a solution to strong CP problem. In our view, xeons are responsible for the lethargy mechanism of gravitation, in whom gravity is an emergent phenomenon. The reason for this multi-component dark matter system is to explain the diversity of very high energy gamma ray sources in the world, the diversity of dark matter cores of macro objects of the world, superclusters, galaxies, and extrasolar systems, which are fermion compact objects and dark matter reactors. Wurm postulates that rest energies of dark matter fermions and bosons are proportional to the basic energy unit E0 multiplied by different exponents of alpha and can be expressed with the following formulas. We still don't have a direct confirmation of dark matter particles' rest energy, but we do have a number of indirect observations. The signatures of dark matter particles' self-annihilation with these expected rest energies are found in spectra of the diffuse gamma ray background and the emissions of various macro objects in the world. We connect observed gamma ray spectra with the structure of macro objects, nuclei, and shells composition. Self-annihilation of those dark matter particles can give rise to any combination of gamma ray lines. Thus, the diversity of very high energy gamma ray sources in the world has a clear explanation. In this regard, it is worth recalling a story about neutrinos. The neutrino was postulated first by Pauli in 1930 to explain how beta decay could conserve energy, momentum, and angular momentum spin. But we still don't know the values of neutrino masses. Although we still cannot measure neutrinos' masses directly, no one doubts their existence. Neutrons serve as another example. The mass of a neutron cannot be directly determined by mass spectrometry since it has no electric charge. But since the masses of a proton and of a deuteron can be measured with a mass spectrometer, the mass of a neutron can be deduced by subtracting proton mass from deuteron mass, with the difference being the mass of a neutron plus the binding energy of the theory. Dark matter particles do not possess an electric charge. Their masses cannot be directly measured by mass spectrometry. Hence, they can be observed only indirectly due to their self-annihilation and irradiation of gamma quants. We will discuss it below. Distribution of Wolf's energy density. Our model holds that energy density of all types of self-annihilated dark matter particles is proportional to a basic proton energy density unit in the medium rho p in all times that in the present epoch equals to this equation. It's about 4.8% of the whole matter, where rho critical is the critical energy density of the world. In all, there are 6 different types of dark matter particles. Then the total energy density of dark matter particles is 28.8%. That is in a good agreement with results of the literature. The total Xion energy density is about 64%. The total baryonic energy density is about 7.2%. The sum of electron and microwave background radiation energy density equals to this value. We take energy density of neutrinos equal to MBR energy density. For fine infrared background radiation energy density, we take this value. Then the energy density of the world equals to the theoretical critical energy density. From this equation, we can calculate a value of 1 over alpha using electron to proton mass ratio, which is in excellent agreement with the commonly adopted value. It follows that there is a direct correlation between constant alpha and this ratio, expressed by the obtained equation. As shown, this ratio is not an independent constant, but is instead derived from alpha. I wanna mention now that there is no dark energy in my model. As the conclusion, the world's energy density is inversely proportional to the dimensionless time-varying parameter Q in all cosmological times. The particle's relative energy density are proportional to constant alpha. Macro-object shell model. In boom, macrostructures of the world, superclusters, galaxies, extrasolar systems have nuclei made up of dark matter fermions, which are surrounded by shells composed of dark matter and baryonic matter. The shells envelop one another like a Russian doll. The lighter a particle, the greater the radius and the mass of its shell. Innermost shells are the smallest and are made up of the heaviest particles. Outer shells are larger and consist of lighter particles. We developed a theory of fermion compact objects. A proposed weak interaction of dark matter particles provides integrity of all shells. Table 1 describes parameters of macro objects cos, which are 3D fluid balls with a very high viscosity and function as a solid-state object. The calculated the parameters of the shells show that nuclei made up of DM1, DM2 compose cores of dark stars in galaxies and normal stars in extrasolar systems. Shells of DMF3 and electron-positron plasma around nuclei made of DMF1 and DMF2 make up cores of galaxies. Nuclei made up of DMF1 and or DMF2 surrounded by shells of DMF3 and DMF4 compose cores of superclusters. According to whom, cores of galaxies are dark matter compact objects made up of DMF1, DMF2 with shells of DMF3 with the calculated maximum mass of 6 multiplied 10 to the power 10 mass of the Sun. This value is in a good agreement with the experimentally obtained value of the most massive black hole ever found, with a mass of 6.6 multiplied 10 to the power 10 mass of the Sun, at the center of Ton 618. It is worth noting that there are no black holes in WOMB. Dark matter particle signatures in gamma ray spectrum. Dark matter particle self-annihilation is proportional to the square of the dark matter density, and it's especially efficient in places of highest concentration of dark matter particles, such as the compact stars built up from fermionic dark matter particles. By definition, X-rays are emitted by electrons outside of the nucleus, while gamma rays are emitted by the nucleus, in whom the self-annihilation of dark matter particles gives rise to gamma radiations. Physicists working in the field of X-ray and gamma-ray astronomy attempt to determine masses of dark matter particles which would fit experimental results with the developed models. WOMB has principally different approach. The model predicts existence of multi-component dark matter system consisting of dark matter particles with these values of rest energies, and look for signs of a self-annihilation of these particles in the observed gamma-ray spectrum. We connect gamma-ray spectra with the structure, core, and shells composition of macro objects. In frames of WOMB, no macro objects are made up of just a single type of dark matter particles, since other dark matter particles, as well as the baryonic matter, are present in the shells. It follows that macro objects irradiate gamma quants in different spectral ranges with ratios of fluxes depending on structure of a given macro object. DMF 1.3 tera-electron volt. Chavez et al. Have found that a significant fraction of galactic very high energy gamma ray sources do not appear to have obvious counterparts at other wavelengths. In frames of WOMB, the correlation between kiloelectron volts and teraelectron volts emission can be easily explained by the self-annihilation of DMF3 with 3.7 kiloelectron rest energy, in the shell around the core of active galactic nucleus, made up of DMF1 of 1.3 teraelectron volts. Lack of a counterpart in gamma ray spectrum means the DMF3 shell is too small to be observed. A detailed analysis of interpretation of latest data of different collaborations in terms of dark matter annihilation and decay in various propagation models showed that for the Fermi Lab and Hess data, dark matter particle mass is to be around 1 to 1.5 teraelectron volt, which is in a good agreement with the predicted mass of DMF1, 1.3 teraelectron volt. Look how many references I have. The presence of spectral break at 1.3 teraelectron volts in very high energy spectra was measured for different blazars. Some nearby sources have unique signatures in the teraelectron region. Broken power law at 1.3 teraelectron volt. The dark matter interpretations of the electron-positron excess observed by Pamela, Fermi, and Ethics suggest the dark matter particle mass of 1.3 teraelectron volt. Look at these publications. DMF2, 9.6 gigaelectron volt. Hooper summarized and discussed the body of evidence which has accumulated in favor of dark matter in the form of approximately 10 gigaelectron particles, including the spectrum and angular distribution of gamma rays from the galactic center, the synchrotron emission from the Milky Way's radio filament, the diffuse synchrotron emission from the inner galaxy, and lower energy signals from the direct detection experiments Gamma, Libra, Cocaine, and CREST-2. It is worth noting that a similar excess of gamma rays was observed in the central region of Andromeda Galaxy 2. McDaniel found that the best fitting models are with the dark matter mass 11 gigaelectron volts. Based on a great observation, Sri Kumar et al. Attribute very high energy emissions to blazars. Most of the measured spectra of individual blazars only extend to several gigaelectron volts and none extend above 10 gigaelectron volts. Bohm proposes that cores of blazars are composed of self-annihilating dark matter fermion 2, 9.6 gigaelectron volts, explaining why no observed radiation extends above 10 gigaelectron volts. Dirac, 70 megaelectron volts. Hunter discussed a peak of 67.5 megaelectron volts. Below 100 megaelectron volts, gamma rays produced via electron Bremsstrahlung and the dominant component of the observed spectrum, whereas above and about 100 megaelectron volts, the gamma rays from pion decay are the dominant component of the spectrum. 70 megaelectron volt peak in a great data was discussed by Golubkov and Khlopov, who explained it by the decay of pion meson produced in nuclear reactions. Wolf et al. Said that gamma rays at 70 megaelectron volt are detectable by glass and infrared. Yamazaki and Nakamura attribute this peak in the emission spectrum from the old supernova rendered to pion decay. Note that whenever the 70 megaelectron volt peak appears in gamma ray spectrum, it is always attributed to pion decay. We claim that pion decay produces the set 67.5 megaelectron volt peak, while Dirac's self-annihilation is responsible for 70 megaelectron volt peak. To find out the source of the observed broad peak about 70 megaelectron volts, we suggest utilization of exponentially cut-off power law as usual for analysis of experimental data for gamma ray energies less than 70 megaelectron volts. A better fit of experimental data will be evidence of Dirac self-annihilation. LOP 340 kiloelectron volts. Existence of dark matter particles of similar mass, less than 0.42 megaelectron volts, has been discussed by Rassera. The experimental 100-400 kiloelectron volt bump discussed by Jarsky is in a good agreement with the theoretical analysis of Rassera et al. And with self-annihilation of dark matter particles alone. Gruber et al. Described a wide gamma ray extragalactic background spectrum between 1 kiloelectron volt and 10 kiloelectron volt, and conclude that the fit required the sum of 3 power laws, according to whom the fit of the total diffuse spectrum in the range between 3 kiloelectron volt and 10 gigaelectron volt should be performed based on 3 exponentially cut-off power laws with injection spectral with this equation, with the spectral index gamma and E cut being the cutoff energy of the source spectrum. For values of E cut, we should use 9.6 gigaelectron volt in the range 9.6 gigaelectron volts, 7 megaelectron volt range. 70 megaelectron volts in the 70 megaelectron volts, 340 kiloelectron volt range. 340 kiloelectron volts self-annihilating LOPs in the 340 kiloelectron volts, 3.7 kiloelectron volt range. They fit in the range between 9.6 gigaelectron volt and 1.3 teraelectron volt should be done with E cut 1.3 teraelectron volt. DMF3, 3.7 kiloelectron volt. The very first signature of the emission around 3.7 kiloelectron volts was found in 1967 by Gorenstein et al. They found that the highest number of net counts is recorded in the beam centered at 375 kiloelectron volts. An important result was obtained by Saki Harvey and Ogelman in 1997. They reported the observations of the X-ray lobes of the large galactic source W50. A broken power law model gives the best fit. The power law indices gamma are 1.9 and 3.6 with the break of current at 3.7 kiloelectron volts as Bloom proposed. Ito analyzed the broadband 3 to 550 kiloelectron volt spectra of NGC 4388 and found line light residual around 3.7 kiloelectron volts at the high confidence level. In 2012, Moretti et al. Measured the diffuse gamma ray emission at the deepest level and with the best accuracy available. Emission line around 3.7 kiloelectron volt is clearly visible in the obtained spectrum. DMF 4, 0.2 electron volts. Unidentified infrared emission bands are infrared discrete emissions from circumstellar regions, interstellar media, star-forming regions, and extragalactic objects for which the identity of the emitting materials is unknown. They are in fact the fingerprints of all galaxies. The main infrared features occur around peaks at 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers, with the photons rest energy at these peaks with this value, and respectively. This phenomenon has been studied for about 45 years. The prevailing hypothesis that the materials responsible for this phenomenon are polycyclic, aromatic hydrocarbon molecules, which are thought to be one of the main forms in which carbon exists in space. And yet, not a single member of this group of compounds had been identified in space definitively until now. Can you believe in so complicated chemistry in the whole universe? In whom, by analogy with electron-positron annihilation, we suppose that particles DMF4 and BDMF4 self-annihilate with the emission of 2 or 3 gamma quants. Indeed, the self-annihilation of them follows an energy conservation requirement. 2 BDMF4 particles with the rest energy 0.38 electron volts can produce 2 gamma quants with this energy 3.3 micrometers. 2 DMF4 particles 0.199 electron volts can produce 2 gamma quants with energy 0.2 electron volts that corresponds to 6.2 micrometers wavelength. 2 DMF4 particles can produce 3 gamma quants with energies equivalent to 7.7 micrometers, 8.6 micrometers, 11.2 micrometers, and 12.7 micrometers. Xenon, 5.3 microelectron volts. Concentration of xeons, the rest energy 5287 microelectron volts, inside of dark matter clouds is considerably larger, 5 orders of magnitude, than in the intergalactic medium. They are ultra-relativistic particles and have total energies larger than the rest energy up to this value 5.87 microelectron volts. A self-annihilation of an ensemble of xeons with energies around 5874 microelectron volts produces 21 centimeter radiation with broad line width about 200 kilometers per second, in frames of whom there is no need in hydrogen atoms, for which there is no explanation for a mechanism of their production. Dark galaxies are made of dark matter particles only. Conclusion. Dark matter is abundant. 2.4% of ordinary matter is in superclusters, galaxies, stars, planets, etc. 4.8% of ordinary matter is in the medium of the world. The remaining 92.8% is dark matter. That dark matter is omnipresent. 2/3 of the total dark matter is in the medium of the world. 1/3 of the total dark matter is in macro objects of the world. Dark matter reactors in cause of all gravitationally rounded macro objects. Whom predicts existence of dark matter particles with these rest energies. We should concentrate our efforts on the observations of cosmic gamma rays with spectral lines corresponding to the predicted values of dark matter particles' rest energy. In our view, great experimental results and observations achieved by astronomy should be analyzed through the prism of whom. Astronomers should plan new targeted experiments based on the results of this analysis, considering the GWST discoveries, successes of whom, and 86 years of Dirac proposal. It is high time to make a paradigm shift for dark matter cosmology and classical physics. As usual, acknowledgements. I'm always grateful to academician Prokhorov and Professor Malenkov, whose influence on my scientific life has been decisive. I'm eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I'm very grateful to Nick Percival for his useful comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify the model and improve its understanding. Thank you so much for your attention. I'm ready to answer all your questions. Bye now.
Thank you very much. And let me see, I'll just bring down the presentation just for the moment. Right. And as usual, you didn't disappoint. You've more than covered the subject that you undertook to. And there have been a number of questions coming in, which I'm trying to keep an eye on, as well as looking at your detailed presentation.
Heaviside in 1893, he started with electromagnetic Maxwell equations, and he put the same equations for gravitomagnetic. Constant, the same C, everything the same. That's why analogy between electromagnetism and gravitomagnetism, Heaviside put in equations with the same value of C, gravitation parameter too. I mean gravitodynamic constant C. That's why, I'm following history of the physics. My main concern was, what? We don't know history of physics. For myself, I opened so many genius people, so many great scientists, and we missed all of them. Our contemporary physicists, they don't know, maybe forgot all these extraordinary results, like John Michel or somebody else, It's unbelievable for me how bad we know history of physics and how many genius ideas we missed. And what is my proposal, my model, is the main goal of my model, is to collect all these genius ideas forgotten by contemporary physicists in one ensemble, in one model, and then we'll play all different, it will be one orchestra, and the model is like a conductor of this orchestra to play with all these ideas, with all these instruments at once. The second question is hypersphere. Of course, Riemann, he was a mathematician. He proposed this idea of the world, hypersphere world, as a mathematician. And I saturated this mathematical hypothesis with the physical parameters. I mean, the medium, macro object, and the spreading of this sphere, hypersphere. Why? Because we know that there is some spreading of the galaxies, of the stars around us. That's why we should explain it some way. Hypothesis of hypersphere world is very important for my model because we have continuously accepting new dark matter. How to have a homogeneous saturation of our world by the surrounding universe. How? This is only one way to have a hypersphere and to saturate our world with new dark matter particles continuously. This is a very important point for hypersphere world.
And it's quite impressive. Obviously, the results of your analysis and the precision of the agreement with the experiment is impressive. So, Nick,
yes.
We have you now. You haven't gone yet. The floor is
Yes.
yours.
First of all, thank you very much, Vladimir. The CMPS is not really heavy in cosmology, so it's really a treat to have this fire hose of empirical evidence and many interpretations of this empirical evidence from some of the major figures in physics and astronomy. I wonder if you could read the first paragraph of dark matter again?
Yes,
Yes, the first paragraph under dark stars, yes.
I can read if you need. The basic feeling of many physicists is that dark matter does not exist because they believe the dark matter concept was erroneously created due to a false analysis of the expected rotational velocity of stars in the outer range of spiral galaxies, and also presumably due to a lack of knowledge about other evidence for dark matter. Is absolutely right. First of all, let me tell you, rotation curves explained by mass currents by Ludwig in 2021, and I'm so happy that at last it happened. That's why you don't need dark matter to prove it, to confirm. The next very important point, I gave you the knowledge history of dark matter for 240 years. The next question is very important. I provide you with all the experimental results confirming that dark matter does exist. I gave you the names of the great scientists, Paul Poincaré, it doesn't matter, Lord Kelvin, and all of them, they were involved in this dark matter investigation. They're not crazy. I used, the ideas of our Nobel Prize laureate in physics about the annihilation of dark matter, and so on and so on. As I told you, my main goal was to collect all these great ideas in one picture and to be a conductor of this orchestra. That's it. That's why take a look. My even today my presentation, most of it experimental results confirming existence of dark matter.